Okay, example 5 is exactly the same. Determine the interval of convergence and radius of convergence. One more time, we're using the ratio test. Actual value. That part is not important because it's actual value. I don't care the sign. It's x to the k plus 1 divided by 2k plus 1 factorial times reciprocal 2k factorial divided by x to the k. 2k plus 1 factorial is equivalent to, say, 2k plus 2 distributed here, factorial. Okay, is equivalent to k plus 2 times 2k plus 1 times 2k factorial. And 2k factorial is cancelled. Entonces stay 1 over 2k plus 2. 2k plus 1 and 1 actual value x. And you apply the limit of this when the k approaches to infinity. Es obvio que this limit is 0. When 0 times something is 0, the answer is 0 is less than 1. That means that always, independent of the x value, this series converge. Therefore, the interval of convergence is from negative infinity to positive infinity, and the radius of convergence is also infinity. Okay, example 6. In this case, easy because I can see that we can express it this series like that. Now this is typical format of the geometric series. And the condition for the geometry series is the actual value of the convergence is that one. In this case, not necessarily apply the ratio test, or if you apply, you get the same result, of course. Now this is inequality. Just this inequality solution is x over 2 less than negative 1 and less than positive 1. Multiplication by 2 minus 2 less than x less than positive 2. Therefore, the interval of convergence is from negative 2 to positive 2. It's obvious that the endpoint, let's see what happens in the endpoint. So suppose that x is negative 2. Just the series summation k1 to infinity to the bottom, negative 2 divided by 2 is negative 1. We see before, this is divergence. And x equals positive 2 is 1 to the k is also divergent. And therefore, this is the interval of convergence, and the radius converges too. Okay, easy. Okay, this example is the combination of two series. So we can separate like that. Look. X raised to the k power divided by k squared plus another series k a to the k divided by 2. Okay, and we compared before this and this and this we did before in the other example. That was exactly the previous example, and the interval of convergence in this case was from negative 2 to positive 2 in this, and the interval of convergence in this case was from negative 1 to positive 1. Okay, now What is the interval of convergence of this series? Is the combination of what is the intersection? And the intersection between -1 and 1, close interval intersection, -2, 2, is a common part, is -1 to 1. Okay. Okay, in this case again we determine the interval of convergence and the radius of convergence. Not necessarily do it by scratch, because I can see that this is a cubic. Okay, this do not depending of k from k1 to infinity of the x raised to the k power divided by k squared. And you recognize this example that the interval of convergence is bracket -1, 1. Therefore, the interval of convergence also for this is the same. And the radius of convergence is 1.